OK. All right, everybody. First time streaming on YouTube. There's always a first time for everything, and why not use a pre-order countdown to do your first live stream? Let's see what we have here. So let me just make sure this is working. Do we have audio? Do we have anybody listening out there right now who can confirm some audio? I suppose I'll be sitting here designing binoculars while waiting for people to show up. And type your questions in the chat, and I will be answering those for everybody as I see them come through on the chat. First time streaming on YouTube, first time streaming through OBS on YouTube. I'm sure it'll all go great. So what we are designing here right now is the altitude trunnions on Analog Sky Bloom. We're updating these with some changes that I would like to make. So we're going to be moving some components around here a little bit and adding compatibility for a couple different kinds of bearing. We're going to keep working on the roller bearings together with the motion control device, but we're also going to be trying UHMW bearings for a cheap and cheerful solution that might work just as well as the fancy, complicated motion control device system. So we're going to test both of those, and we are going to see which one works better. And that's the one we are going to do. So I am hiding that motion control device because we are not worried about that right now. I'm just going to sneak back over to my other window to see how this live stream is going. If anybody wants to type into the chat, let us know whether or not you can hear. That would be awesome. Anybody want? Oh, I just took a little quick listen to the actual live stream, and I got some audio through. So I'll just assume that that's actually working. All right, so this is Analog Sky Bloom, by the way. These are the largest binoculars in the world that you can buy. They are for looking at outer space, and they're designed specifically in order to do that. They're not designed for pointing at the Earth or pointing at ships on the sea and then also being used to point at the sky. These are actually astronomy binoculars designed from the ground up to point at outer space. And that makes a huge difference in whether or not they are fun to use for pointing at outer space. Analog Sky is pretty much the only company in the world that actually designs binoculars for that purpose. So one thing we're doing is adding some support to this trunnion to make sure that it is nice and strong. probably also going to add a cross member to stiffen up the OTA a little bit more. And so this is an actually live look at modeling these things piece by piece. So we'll see if this is something, if this this is the new hot content that everybody wants to check out on YouTube. I know recently I saw someone live streaming designing their astrograph on YouTube, and that was pretty neat to see. I have to admit, I did not expect to see that happening on YouTube. But these binoculars are strictly for looking through. They are not for taking pictures with. And binoculars are a much better way. If you're going to look at the real universe with your own eyeballs, binoculars are a far better way to do that than squinting through one eyeball. They are much more comfortable. They're brighter, they're sharper, and the image is just overall better. They're higher contrast. You can see really faint things. And you can see dark nebulae. If you're a fan of dark nebulae, you can see dark nebulae better with binoculars than anything else in the world. Nothing else really comes close. And so that's why we go through all this trouble to create the best binoculars you can get for astronomy. So it really does make a huge, huge difference. So, oh, we've got our first comment in the chat. Orion Repus, big fan of office hours style streams, always a lot to learn. Welcome. Yeah, these, I haven't caught too many of these myself, but let's see what we can all learn together here today. Let's see what we got. Actually, let's just do... Okay. So, let's see. Let's go with a nice even number. So, that's all good. So what I am creating here right now is a little crossbar that is going to stiffen up these altitude trunnions for our Dobsonian style mount here. So these large altitude trunnions make it really smooth to move these large binoculars, and it makes it distributes weight really nicely so that any shifts in weight from changing eyepieces or different accessories while you're using your binoculars is handled smoothly by these gargantuan altitude bearings. If you look at a classic Dobsonian style telescope like the ones John Dobson himself created, they have really small altitude bearings which do work. You just have to have a very precisely balanced telescope and kind of use eyepieces that are all about the same weight and things like that. So these larger bearings give us a lot more flexibility. So let's go with like, so what I'm looking at right now is just, is there an angle to insert a cross bar that kind of makes sense. You know, one other thing I could do is invite everybody over here. Let's invite our own community. No, that's not what I want. Create event. And let's bring that up. Let's see. Sky live. And we'll just copy that URL into here. And we'll just post that. So we have our own community of users. Who all have a little private social network where we share our ideas about stargazing, our ideas about how to build our binoculars better, our ideas about what binoculars to build next, what eyepieces to use, all that fun kind of stuff is over for free at members.analogsky.co. You can just sign up for that and check out some of our forums and stuff. And I can even bring that up over here real quick. I can show you what that looks like. We have a cool platform that is called Mighty Networks. And this has an announcements area, and then we have a little public group called the Beehive where we talk about whatever we like. This is open to everybody for free. So what we have here is people talking about this great sale that's going on for telescope eyepieces, which we use in our binoculars. We have some stuff about the comets that are up in the sky right now. We have a little barking poodle. We have some cool ideas about how to use a long-range communication. We have some of our binoculars posted in the site. All right, we have our first dog bark. It only took about 15 minutes to get our first dog bark in this live stream. And maybe next time I will close up the door. Hey, Bubby. Hey, Bubby, come here. Come here, buddy. Come on over here. So anyhow, we have this cool area for everybody to join up for free. And then, of course, you have your binocular courses that show you how to build your analog sky binoculars step by step. So this is the place where I just posted a little notice about how we have this live stream going on. But enough of that. Back to... Hey, puppy. Puppy. Here, maybe we'll put a mute. Is that a mute? That is not a mute. Alright, so we can see here that this piece of aluminum, as is, weighs almost a kilogram, which is a lot of weight. We don't want it to be a whole kilo. And this is at 3/8 inch thick. So we are going to want to put some holes in here and make this a little bit lightweight, but I'm just starting to get a feel for what this part could do inside of our assembly. Part of designing within your CAD software is just that you're kind of learning as you go. CAD software is really designed so that you already have an incredibly concrete idea in your mind, and then you are just putting that into the CAD software. Whereas, in my reality at least, what is going on is I am figuring it out as I go inside the CAD, which leads to a little bit messier CAD files and who knows, maybe a more exciting process. But what I'm looking at is if we rotate this, does it clear what's going on down here with the rocker box? I don't really see any clearance issues that way, but that's why we can go in here and rotate some of this stuff. We can grab these two parts and we can rotate them along this axis here. Then we can start to see, is there going to be an issue when we do that? Okay. Hey, buddy. Hi. So we have our shop dog Pumpkin here with us. You can say hi to the world, Pumpkin. You're on YouTube for the first time. Yeah. Not real happy about it. Mm-hmm. All right. Yeah, you can hang out here with me. Okay, so basically this altitude trunnion, we have two places where this connects right now to the mirror box. We have this spot right here, and we have this spot right here. So that's the main way we're stabilizing that, along with, of course, our trusses up here towards the top. And one issue is you get kind of a parallelogram shift if you don't stabilize along the bottom here. One idea is to stabilize it with just another, we can do that with another truss, but that might not totally deal with the whole parallelogram issue because it can still sort of do that shear thing. Whereas something extended, a profile like this that's extended somewhat, does not have that issue. So we can look at our profile sketch here, and maybe we'll go down to 100. We'll make a short one. But then what we're going to do is convert this into a sheet metal component. There we go. Our sheet metal rule is going to be 1/8 inch 50-52. Yep. Alright, so now we have a piece of sheet metal, and we can add a flange here. So this flange kind of is fighting the curve of our trunnion a little bit. How about we go the other way? That makes more sense to me. And our initial profile is a little, needs to rotate a little bit, but we get the idea. So by creating this bend, we're just adding stiffness to this entire part without really increasing its weight at all. And we like that. Of course, it's still going to be a kilogram, so we have to make it lighter by cutting holes in it, but that will come a little bit later. So let's increase this angle a little bit up to like 65 degrees. Yeah, that looks pretty good. And now we can see that's kind of comfortably fitting within that profile of the altitude trunnion. So it's just a little bit of a subtle bend, but it is turning our 1/8 inch thick part into like a 1/2 inch thick part. So that's why bending is so powerful. I'm not an engineer. I can't give you an equation for that, but basically when you add a bend, it's like increasing the thickness. Feel free to chime in with your engineering insights, anybody out there in the chat. So one question is, can we make a part like this that does double duty as something else? So can this be a cover for our secondary, our kind of UTA assembly? So let's just go ahead and move this up here and see if it's useful at all for that. If we rotate it this way, does it kind of work as a protective metal cover for our delicate secondary cage and tertiaries and all that? Well, looks like that doesn't actually go very far. To be only 8 inches long, we still have quite a ways to go for this to be covering our kind of 14-inch deep situation here. And it might add quite a bit to the height too, inadvertently. So if we come down here and we kind of try to maximize our use of space here, it really needs to rotate this way. And now it's I don't know. It's more critical that it is hovering over the secondary assembly than it is over the tertiary assembly, because the tertiary mirrors are already pretty well protected, whereas these secondary mirrors and their spiders are just a little bit more exposed. So, can this part in travel mode be useful here? I don't know. It certainly fits within the width nicely. It's the correct width for sure. But I don't know. I will have to think about that. Whether or not this makes for a useful part in that sense. It seems like just having an actual case that has been vacuum formed is probably the way to go. Okay. Another issue is if I'm an eyepiece, I guess that's the thing to think about here. If we come down here to our eyepiece rack and we imagine that I'm an eyepiece, and I stick out from the eyepiece rack, how does that run into me? So let's say I stick out. I could be 4 inches tall if I were Morpheus. Actually, a Morpheus 4.5 is about 4 inches tall. I should probably measure that real quick. That's a great idea. Let me go grab my Morpheus 4.5 and actually measure it, because I don't know if that's actually contained in the big spreadsheet. Okay, Morpheus 4.5. Where are we at here? I'm guessing we are right at 103 millimeters for the full height of that Morpheus 4.5. So I'm spying one problem with this idea. And that is clearing our eyepiece rack, which is an enormously useful eyepiece rack. So here's the thing is, if we put this part, and let's just go here. So the way this rotates is that this whole altitude trunnion is going to rotate clockwise this way. in order to get down to the horizon. So if our stabilizer is over here on the other side of the eyepieces, then it's not a problem because it just rotates down, down, down. And this is the maximum it can rotate up. So one concept would be simply to stop right here with our stabilizer, and then won't be a problem. So let's look at this flange, and maybe instead of 100 millimeters, we're only coming up 30 millimeters. And how does that treat us? Okay. So now we are clearing our eyepieces. But are we actually stabilizing a whole lot more? Because we kind of want to split the difference as we're stabilizing. We have a rod going across here, and then we are, you know, attached really firmly down here. So adding this piece in here, does that really get us where we want to go? Or would we be better off moving to higher ground? No, we don't want to edit the feature. Actually, maybe I can just move this part right now. So if I just move this body and we go up, 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 and we rotate so that we are going to do this up here, should we add a little bit of metal to our altitude trunnion so that this stabilizer clears the eyepieces in the eyepiece rack? So we have a few more people joining us here. Welcome. We are on a countdown for Analog Sky Bloom. I'm just going to throw that in the chat. So Bloom is our 200 millimeter or 8-inch reverse binocular, the biggest pair of binoculars in the whole entire world that you can buy at least. And these are just for looking at outer space. And I just popped a link into the chat about all about these binoculars because we are in a drive for the last few hours of doing our first pre-orders. So this is the first batch of pre-orders for February 2026 delivery is the plan. And so this is the first version of these binoculars. And we probably aren't going to do another batch until 2020. You know, we won't run pre-orders until this time next year for 2027 delivery, because this is a huge project to put together a batch of these. And this is your opportunity to get the most immersive astronomy experience in the whole wide world for using it next year instead of 2 years from now. So yeah, I'm kind of liking this idea of just trying to clear the eyepieces, and then we have our cross brace here that makes those altitude trunnions a rectangle instead of a crazy parallelogram. So let's see how far we can extend this concept. If we go this way, okay, so that creates a lot of stability for us, and it clears our eyepiece rack, no sweat. So that's an interesting concept. We would probably split the difference on the bend, maybe move the bend up, but I don't know, having the bend down there does have the advantage of giving us more room to put our eyepieces. I don't know if this also gives us a platform for our shroud to do more shrouding down low. This is a good question. Where are we at on weight right now? We are at 1.2 kilograms. So if I cut half of that away, we are at half a kilo, or coming in close to 1.5 pounds for this. So one of these struts is going to be much, 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 much lighter than this. But would also need to clear the eyepiece holder. And we got a question, is there enough clearance to remove the eyepiece? And that is also a great question. So this is, we're looking at the eyepiece going in. That eyepiece has usually your barrel right here is about an inch long. Yeah, these are right at about 23 millimeters. So we'll call it 30, maybe. Some of them are up to 30. So that's the question is, can we move up a bare minimum? Oops, not faces, we want bodies. So can we move up a bare minimum of 30 millimeters here to get that eyepiece out? And there is a bare minimum of 30, but not a whole lot more. Right now we got 40. So that gives us a little bit of wiggle room for our very tallest eyepieces. Ooh, let's see. Hello? All right. We got some spam callers on the live stream. I wish we could have call-ins for the live stream. That would be funny. That was just a spam caller. They were not interested in binoculars, unfortunately. So yeah, what do we have? Up to maybe 50, almost 50 millimeters, let's say, of clearance here. I think that's pretty good, honestly. These are just kind of the worst case scenario eyepieces. I don't know of a single eyepiece that's longer than this. I'm sure it exists, but this is a Morpheus 4.5, and these are very long eyepieces. All right. So we have some clearance here. We have a, let's see if it's longer. one thing that a lot of people will do is you could also use this on the bottom to protect the screws on the primary mirrors. That could be a thing. Yeah, I don't know. I don't really know that this is a thing. Anyhow, if you have questions about Analog Sky Bloom after perusing the information there about it, we have a countdown to signing up for the pre-orders, and I am happy to answer any questions you might have about how the pre-orders work, how the binoculars work. We just sent out an email to our mailing list with some nice words from Mel Bartels. And let's see, I am checking my own email real quick here just to see if that has resulted in any questions via email. But I don't see any right now. I'm actually all caught up on my email, and that's pretty crazy. And okay. All right, we're caught up on email for once. That's why we are taking a moment to just do some design work here. So yeah, this is one concept. I think what we'll do is just come up with a crossbar like this. We'll cut some holes in it and just see how this works compared to a strut. It just goes all the way across. My kind of sense and hope is that a strut would do just about as good a job as this large part, because this is just very heavy and would be an odd shaped piece to add to the kit, which I mean, I guess the good thing is that it's not strictly critical, so if you did forget this part, it would not be the end of the world by a long shot. So that's kind of where we're balancing absolute precision versus just functionality and ease of assembly and weight and all that good stuff. And do we really need to go with a part like this, or actually I'm not going to do it that way. Let's just go right in the middle. All right, there's no middle because that's not the right length. There we go. We'll go here. This feels like it's not getting too flimsy. Might want some of those to be a little bit thicker. I just want to kind of see what we're looking at for weight here, get a rough weight estimate. So we are down to 863 grams, down from about a kilo. So it looks like we have removed a lot of material, but it's actually Still a lot there. Alright, so let's take a look real quick. I believe this is our center line here. Let's just create a sketch for a 15mm tube. And where that would go. So we are going to, once again, it looks like we're going to wait. For the CAD to catch up. So let's create a little reference circle, which is the top of our, it's going to be the top of our eyepiece. In our eyepiece holder, we just want to make sure we're staying within this circle when we swing around with our tube. So this, let's grab that center point, create a little reference line, and then we'll drag out a line to our tube so that way we can figure out what this angle is. And I think if we do a 45, that means we're just kind of splitting the difference on the whole circle, but that's not quite where we want to be. Let's call this like 55. Yeah, that feels more centered because we want to be in between this conjunction. We're basically going to add this back to the toolbar because Fusion took it away. So we're going to just do this a little bit more scientifically. We're going to add another reference line to there, and then we're going to look at where this other tube leaves us, and that tube leaves us up here on this circle. So let's take a look at this angle between these two. And then we are going to call this angle now this angle divided by 2. And we were 54.9. So, well, now we're more accurate. So, I just wanted to make sure I was kind of putting a support halfway in between where this support leaves us and half where we pick up the support again up here. I eyeballed it at 55 degrees. It turns out the exact number is 54.9. So I guess we were pretty much in the right place there. We got a question. John is asking about audio, and yeah, I think the audio is coming through on the stream okay. Thanks for checking, though. This is my first time streaming live on YouTube. So it's actually pretty impressive how well OBS, the streaming software, handles the connection to your YouTube account and pops all of the YouTube settings directly into its own interface and stuff. That's really neat. I didn't think it would be that easy. Great piece of software for free. Okay. So this is where we would put this tube. So we're going to do, let's see, I think this is what, 300? No. let's go the other way. This must be a 250 millimeters. Yep, that's right. So that's going to be a 250 millimeter, and we are going to have symmetric 250. Well, we want to represent it as two separate struts. So there's a strut. That's what a strut would look like. If we connected it over to this altitude bearing over here, then that would give us a strut kind of in between the other two connection points. Yeah, I don't know. I'm feeling like I like that better, because part of the whole parallelogram thing with this larger piece also is that you have to connect it to these altitude trunnions. And so that means we need brackets to screw these components together. And so not only are those brackets an extra part to design and possibly leave behind, those are going to, be more setup time in the field. I would really like this strut right here to work and do the thing that we want it to. We certainly, we've added these spokes, these radial spokes to our altitude trunnions, and so I think those are going to make our altitude trunnions stiffer in general. And by adding these extra struts here in the middle, I think it's at least going to cut our parallelogram tendencies in half. And cutting them in half is pretty good for the weight and the extra setup and everything. Whereas this large piece would probably be extremely effective, but also just feels like a big hassle. It's a lot of extra hardware. It's a lot of extra connection points. It's you at least have to connect the four corners instead of just the ends of these struts. So you can see here we just have one knob that goes through the strut end here and connects all the way through to the end of this strut. These two struts are connected to one another, and then it comes up back out the other side the same way. So we would just duplicate that. And so conceptually it works the same. And I think this would be providing us a lot more stiffness. If we were going to do one of these, though, I can at least add the connection holes for where we would put our little brackets, I suppose, just to try out. So let's create a copy. Oop, not that whole component. No, I want this, just the subcomponent here. Ungroup from parent. Is that what we need to do? This is not a therapy session. It's just the words they use for CAD software. Here we go. Let's just copy paste. And this is going to be 250 millimeters over. All right. So that's how that would look. Let's kind of hide this. So this would be what we're looking at here now. I don't know, that's feeling better to me. So let's just take a look real quick. Up here we used a how big is this hole? That is a diameter 6.3, so we used an M6 bolt to connect that. So if we're coming back here to our altitude bearing, and we were we're just going to add this as a projection, and here's our 6.3 millimeter hole for that M6 to go through, and then we need something for it to attach to. So let's call this what looks good, about 30. And then maybe we'll make this look nice. We're going to go from here to here, like this, and then we're going to add a rectangle that where this is going to be perpendicular to this. Okay. And then we will just add one of these. And just make sure I don't understand why that is both blue and does not allow me to move it either. But it's doing what we need it to do. We have a question here. I'm curious if a bino setup such as this suffers from poor seeing in the same way a larger scope does when compared to, say, a 4-inch refractor. Can bino vision see through some of the turbulence? All right, so great question, John. I would say there is certainly a lot of anecdotal lore about binoculars in general, of all different sorts, improving seeing because you are looking through two separate optical columns of air, basically. You know, that starlight has gone through two separate columns of air to get to your eyeballs rather than kind of a bino viewer situation, which is just splitting the same light into two different batches of light. And of course your brain is then using the sharpest parts of each image that it's getting from each eye and creating one sharper image. And so I guess the question is that true? I always kind of soft pedaled that personally because it's pretty hard to quantify, and it sounds a little bit like folk science. However, when I built a pair of 50 millimeter binoculars specifically for looking at the sun in white light, that really changed because we have our 50 millimeter binocular called Sunny, and that's .co/Sunny. Here's where that lives. So it's for looking at the sun in white light. You can see the sunspots, you can see the faculae and everything. And here's the thing, during the day, the seeing is terrible, 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 terrible because all that heat is pouring off of the concrete jungle and it is going back into the sky, and so that's why the sun looks super ripply during the day. And so I was sketching the sun a lot using my solar binoculars just to see, like, oh, what kind of detail can I see with a pair of 50 millimeter solar binoculars where you can change the eyepieces and zoom all the way up to, say, 100x or more with those 50 millimeter binoculars. And what I noticed was that if I closed one eye, it was blurry. And if I closed that eye and opened the other one, that eye looked blurry. and then when I opened them both, it looked razor sharp. And so I did that hundreds and hundreds of times over the course of a couple of months of really kind of intense sketching every couple of days, and really came to the conclusion that that was a pretty true phenomenon for binoculars of all sizes. That my brain was putting together two lousy images, and it's kind of at each moment it's grabbing the sharpest parts of each of those images. I was kind of skeptical as to whether the two images on both sides of a 50 millimeter binocular would be different, because they're just not that far apart. So you hear people talk about how the cells of turbulence inside of in the air itself, that they're about the size of a basketball, right? So you can see in a binocular the size of Bloom here with 8-inch mirrors that are, spread out a little bit. You can imagine that this basketball of air could actually be a totally different basketball of air from this one over here, and that for binoculars of this size, it would really work, right? Well, guess what? It really worked in my 50 millimeter binoculars, and it's not the kind of thing that's very easy to go back. You don't get to go back in time and figure out, like, was that just a sharp moment? What would it have looked like during those moments of seeing? Whether the view through one eye would have been just as sharp as the view through two, but just, I would say, over time of solar sketching, I became much more of a believer, even as a binocular builder, in the power of binoculars improving seeing substantially. So I do not doubt at all that refractor enjoyers, people who like to use like a 4-inch refractor to look at Jupiter, for instance, because it smooths out the seeing and the turbulence compared to looking at it through higher resolution single 8-inch mirror. I think people who enjoy a refractor of that size for that reason would really love binoculars, because it's you're playing the same lottery with twice as many tickets. So I'm just making a little bump out right here on the altitude trunnion that is going to allow us to hang on to this strut. And I don't know why I didn't do this part the first time, because I always hate the way it looks when I use a rectangle. It just looks really dorky. That looks a little bit better. So now that is going to let us connect those struts in the same manner that we are connecting them up here, and I have to design clamps for that. And we have to design holes for the clamps to clamp to the trunnion. But if you've ever wondered what the speed of design is when you're thinking up binoculars that no one's ever made before, it can be a pretty pretty slow and steady process here. So it can take an entire afternoon for me to just kind of figure out, okay, here's this problem I'm trying to solve. How's the best way to go about that? And then actually end up with something new put together. But I'm thinking that this will be my preferred solution for this problem over the sheet metal, because this is going to be about 1/10 of the weight, and I think it's also going to be a pretty good improvement. One other question would be, of course, should we do it as an X rather than as a straight across strut? And that's something to think about too. So we have a little gap here. So the struts that we use are pre-cut components that come from DSLR video rigs. And so we have those in like 200 millimeter, 250 millimeter, 300 millimeter lengths. This is 250. If we go to 300, then it sticks all the way through. It goes too far. Although an interesting question would be, since I have to make a clamp anyhow, why not just go all the way through? See, here's where it gets interesting. Here's where we start designing something that no one has ever done before, which kind of happens on a daily basis here at Analog Sky. So let's take a look at, if we do these as 300 millimeters instead of as 250 millimeters. Yeah, we'll worry about moving this one later. Oops, I didn't mean to move it now. Okay. So if this comes through, if it comes all the way through here, and then we connect it via a clamp to the altitude bearing, which is kind of like a little cinder cone. Then does that have some of that same, does the diameter of this cinder cone that it's attached to help us reduce the parallelogramism even further, so to speak? So if we do this, and then we do this. Oh, I hate how that works. I'll worry about the taper later. The taper is not the important part. But the question is, if we do this, attach this out here. Really? You don't like that, huh? Let's, okay. Which part of this don't you like? Fusion's so funny. It likes that. There we go. Okay. So this is the interesting question, is if we make a clamp for this that clamps on the outside, does that help maintain our parallelism? Just do one of these. That kind of thing. Because now we're kind of squeezing those together from the outside. And we're using this whole surface area here at the bottom of this clamp in order to do it. And it doesn't protrude a whole lot further than the other clamps anyhow. We're talking about an extra ½ inch or 12 millimeters, so not a big deal. And now we can move our rocker box and our ground ring. That all seems pretty good. As you can see, if we go all the way down to 90, all the way down to the horizon, we better not have those 4-inch long eyepieces on the outer edges. So that's going to be a good tip to our users, is if you're going to have 4-inch eyepieces in this eyepiece rack, you better put them in the middle, because they're going to bump the struts if we go all the way down. But I don't see anywhere else that they are bumping into each other, where any of this new stuff is bumping. So that's interesting. I'll have to sleep a little bit on this idea and think about what I think of that method of attachment rather than going to the inside. Because as we clamp down onto the strut itself, we're also clamping down onto the clamp. And that clamp has a large surface area that interfaces with the altitude trunnion, and if we're clamping both sides of that, I feel like we're really shoring up both sides of that altitude trunnion and making it difficult for it to do the parallelogram thing. So That's a fun thing to think about. Sometimes I wish I were a real engineer. It would kind of know how to maybe quantify that, or maybe even if I just knew how to use all of the FEM stuff built into Fusion here, and also had the extra cash to run the FEM analysis, which I'm pretty sure costs extra money to do in Fusion. But trial and error is actually a lot cheaper and I think more valid as a form of experience. So that's what we do here at Analog Sky, is we try things out. I do like that this is creating an extra cage area around the primary mirrors, and maybe we can roll a piece of that flexible plastic up from down here on the mirror box, just all the way up along this strut and up here to the top of our altitude trunnion, and then that can be just kind of a permanent, it would be semi-permanent because we're taking the altitude trunnions off, but that might be another nice way to create some shrouding around the primary mirrors, and also just some protective surface down there. We have a question here. Do you have any timeline or plan for when Magic version 2 will be out? I've been holding off on a second build for my nephew, and the updates all look great. Yeah, we have a lot of people excited about Magic 2 for sure. I'm very excited about it. I can't wait to have one. I'm also very excited because I am working right now. I'm working with somebody on the idea of putting together an upgrade optics set for it that does both field flattening, which makes the edges nice and sharp, and then also to have an ED lens element up front that handles the chromatic aberration when we zoom in. So it's kind of a premium lens upgrade path that will help people with the field flatness and the color to, and you wouldn't have to start there, but you'd be able to grow into those lenses as your budget allow. Anyhow, working on that, and I think that is something that is going to probably affect design a little bit, so I don't want to like lock in the design, even though I'm sure you've seen the design is pretty far along anyhow. So to answer your actual question, we don't have a timeline because that is part of what I'm working on. I really want that to be that lens upgrade path to be an integrated part of the design of Magic 2, and so I'm kind of waiting until we have a solid plan on that. But I would hope that I am kind of wrapping all of that up concurrently to getting the Bloom videos filmed and getting the Bloom stuff out the door like early next year. So we're shipping Bloom in February is the plan, and we'll be working on Magic 2 in little drips and drabs until then, and then releasing it, starting to actually seriously work on that after Bloom is out the door to everybody. So early next year would be the goal. Certainly we'd want to have Magic 2s into people's hands by summer. So we have a question. Hey, Robert, what do you think about an L-shaped sheet metal? Oh, I should say before I leave the Magic 2 conversation, So magic diagonal mirrors, we're waiting for those 30 days ish, 30 to 45 days. Um, 30 to 45 days on that, on those new mirrors, and those are going to be dielectric coated mirrors, so that's like a 99.5% reflectivity on those mirrors. If you put together a Magic 1 using those new mirrors and the stock lenses, which will definitely work with Magic 2, then you do have the opportunity to upgrade a Magic 1 kind of optics to a Magic 2 body when that comes out. So part of the fun of being a telescope maker, a binocular maker, is always like, what's the next build right around the corner? You know, it's like, it's so fun to build a new telescope that you know, at first my mindset was like, once people kind of have their basic binoculars figured out, they're not going to need me anymore. But honestly, realizing that so much of the fun that our community is having actually building these is the same fun that I have in designing and building them. And so we want to keep giving you new ways to build out your existing optics and stuff. So if you're building it with a nephew or building it with a friend or building it even for yourself, two builds is twice the fun. that's my hard pitch. Andre saying, hey Robert, what do you think about the L-shaped sheet metal piece for that strut instead of 15 millimeter rod? Andre, you're late. We covered that. So that's here. I'm joking, of course. So earlier I was kind of working on putting together some kind of a sheet metal part that extends between these two. So something this size, I can probably still cut some holes down here, but this is about 800 grams for this one. That it would kind of have to go across here to keep from running into the eyepiece rack. And then we have to attach that thing on like 4 corners, and I'm starting to look at that and think about like, how do we attach that on 4 corners? We're giving people 4 more thumb screws, and it's weighing all that weight. And I guess what I don't know is just how much better a job it would do than our other plan. And so I don't know if we would do this 300 millimeter thing where it sticks out the ends, or if we would do like a 250 millimeter thing like up here where it doesn't quite make it to the altitude trunnion, but then we just put a little metal spacer in here and it's all good. That's captive to the clamp on the trunnion, so you don't have to worry about that during installation. One of those things would be the goal, and so I don't think we would get, you were talking there about over squeezing with this 300 millimeter concept, and I do see that there is definitely an opportunity to over squeeze there, possibly, and crack those. But I don't know if the 250 would be would have that same problem. So let's see. Andre's saying, I love seeing you think through the design in real time. More of this, please. Okay, yeah, this is kind of fun. I don't mind doing things this way. It's very slow. It's like a snail slow, as you can see. When you don't have a plan and you're going into CAD without a plan, it does take a long time. So Andre's saying I was thinking of a narrower piece like those aluminum channels. You mean like 80/20 kind of channels, like X channels? So maybe two bends to make a square cross section with one open side, like those shelf channel things you can buy at the hardware store. Yeah, I gotcha. Oh, I see. Yeah, a square cross section. I don't know what the limits are on what they can bend that way in terms of making like a sort of a brace with a C-shaped cross section. So you're saying like basically something the same dimensions as this tube, but have it laser cut so that it's exactly the right size, and then it's just kind of like mimicking a tube as kind of an extrusion. So we're basically mimicking an extrusion, but it's a folded sheet metal piece that's all one part. Got it. Okay. That's a cool idea. I would have to look at what the bend limitations are for doing something like that, but I totally dig what you're thinking about. The second issue there is, I guess we could have a bend on the end also for attachment. And I don't know, maybe you just invented a whole new way to make to make telescope struts. That's kind of cool. I'll have to think about that. So I don't know if my words are any clearer. My words are probably less clear than Andre's words because my words are almost always less clear. But the idea, I think, is if we just, Fusion just reset all my buttons. I'll pin this to the toolbar. Here's my favorite type of rectangle. So basically we do a 20 by 20, and then we do an offset of 3.175, and then we make an additional rectangle down here. Basically, then we have a cross section here that can just go all the way this way, all the way to this end. To this end. And now we are creating a new body, and then we can fold down a flap on the ends to be the tapped M6 for connecting it, and then that will get folded flat by the actual things bearing down on it. I don't know if they can do that bend. So that's the only issue there. It might have to be not a square though. We might be able to do it. I think there's a limitation about how tall the bends can be compared to the profile that they're being bent from. I'm you can tell very quickly I don't actually have a manufacturing background. I'm just a guy. But I don't have the right words all the time. But here we go. If we do that. Yeah, I think this they can do no problem. Why is there a little extra down at the bottom? Oh, I kind of did. I must have. Something like this. Here we go. How's that? This they can do for sure. And then we do flaps on the end. Yeah. Yeah, you're smart, Andre. Shoot. That's pretty good. I like that. You can do snaps in the chat for Andre. Andre's also the person who came up with putting a little bit of graphite powder on our focusers to make them smoother. So Andre's racking up the good ideas. Yeah, I like that. That's a pretty good idea. That could work for a lot of things. You know, a lot of times you see telescope builds that use aluminum channel that you get at the hardware store. To me, the issue with the aluminum channel is that you're always having to figure out a way to affix it to other things, and so you end up sort of epoxying connectors to the ends, and then you're hacksawing it to different lengths, and then, you know, people in the United States, we have these giant hardware stores that you can just go to, and you know, you can just get a magic potpourri of every single thing you can possibly think of, but not everyone everywhere has access to hardware stores that has all the same fun things. And so, you know, part of Analog Sky is about really coming up with very standardized components that everyone can share and use. So is that C channel the kind of thing you could go to the hardware store and buy? Yeah, but would it be able to attach to our build? Could you find it in a store in a different country or even a different part of the country? Those are all the questions that we try to answer before creating these kits. And so that's why we have so many custom components, and also why we like 3D printing our custom components, because it's a whole lot easier to print your own components than to have them laser cut out of metal by a $10 million laser. So this is really cool. Yeah, that's the best. That's the best idea. I like that a lot. So we have to do, the way this works is we have to go here and we have to create a component, and then with our new component, is that this one? No, where did it go? It must be this one down here. Here we go. So we go here and we go to sheet metal, and then we convert that to sheet metal, and we do this. We use our sheet metal rule, and now we are inside of our sheet metal thing. And I'm just going to hide this one and hide these ones. And basically what we're doing now is we're creating a flange from here. But we want to go the other way. And it's not going to like that because it's not sticking out far enough. We have to actually extrude a little bit further in order to create that flange. We got to pull back on our legs a little bit. And we have to make those real flanges, because right now they're not real flanges. They're just like they're just kind of a concept. So I'll have to come back in here when I'm actually using my brains and execute this design. But I do really like that concept, because it gives us the dimensional stability while keeping the weight way down, and it's just the exact size. I don't know, I might even switch out I might switch out this one to one of those as well. You know, the other thing that's cool about this is that it doesn't necessarily have to have the C down like this. It could be C up or C left or C right, you know, whatever. But we can drill holes in this for attaching stuff. So if we wanted to have a shroud piece that goes from the mirror box down here up to here, it could actually attach in this midpoint and then attach up at the top, and then it's nice and secure. And I don't know, lots of fun possibilities with that. Dude, this is so cool. This is so much better than I don't know. Telescope making is such a fun thing. I was just at a conference, which I have been invited to run. So in Portland, Oregon, there is a telescope making conference that just had its 18th year. You can go to Howard Banich on YouTube. That's Banich, and find the Portland Alt As conference 18 with 18 is with Roman numerals, and so you can check out there. I gave a talk there this year, but basically it's a telescope making conference of telescope makers from all over the world, showing off all the different projects they've done in the last year. We try to get a wide range of speakers and topics. It's been run by Mel Bartels, probably the most famous telescope maker in the world, and Howard Banich, one of, if not the most famous, I don't know, sketcher, astronomy sketcher. I think he's way up there at the top. His articles are in Sky and Telescope. Howard's also been a telescope maker forever. He's had articles in, Telescope Making magazine, back when that was a real magazine that was a black and white, like real scene zine of telescope making before we had the internet. Howard's been building telescopes forever and is just one of the best sketchers in the world, and awesome guy. Anyhow, conference has been run by Mel and Howard for the last 15-ish years of its 18-year life. They have asked me and Rob Brown to start running that conference. They are ready to retire. So I will be running that conference starting next year. But the reason I bring this up is because it's a lot of fun to share your ideas of how to build telescopes. And we really packed in the presentations this year. There were more presentations than ever, and it left less time to talk about, for us to just mingle and talk about telescope making ideas. And so that is something that Rob and I have already talked about integrating into that conference next year, because look at what happens when I live stream and just kind of go through this design process and have a couple people here to check it out. We get good ideas, better ideas than just coming through one brain, and that benefits everybody. So that is cool. Maybe we'll do this at least once a week. Okay, so there's a plan for stiffening up those trunnions. I see Andre said we can store snacks in the channel. I like that, like M&Ms. just pour M&Ms into the C channel, and then when you're out of M&Ms, it's time to pack it in for the night. I like that idea. All right. Well, I hope this has been an interesting thing for people to check out. I have a hard out here at 3 o'clock. Thank you to everyone for your questions. I am watching all the questions come in on our business email. I'm watching the questions come in on our help desk, which is a completely different system. And hey, we have another. I forgot to check one other email address, and we have another one. Where is my OBS? Here we go. Next serial number. Dun, 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 dun. Bum, 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 bum. The next time I'll have the ActRaiser music, so I don't have to do bum, 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 bum. Here we go. We just sold another bloom. Pre-order. Thank you. I don't want to dox everybody who's ordering, so I won't say your name, but thank you very much for your bloom order, for signing up. And we are trying to get ourselves up into that 40 to 50 pre-orders range by the end of the night. So we did an early access campaign last month just to see how many people were out there in the market for what we're doing here. We got to about 55 people, and we did those. We kind of based our goal for that on 60 people, with the idea that probably not every single person would end up signing up for the pre-order. Of course, having a government shutdown in the middle of this whole process doesn't help. I know we've already had a couple of people who have had to put their pre-orders on hold due to losing contracts or losing jobs, and that's a real bummer for them. Not much more so for them than for us. So I know everybody's going through a whole bunch right now with that, and so we are understanding if not everybody can from the early access can jump onto the pre-orders at this time, and we are just grateful for every single individual who's going to join us in this first group of blooms. It's going to be a really fun process. We have an instrument that's already terrific, and we are going to work out all the little bugs before getting this metal cut. And we're still working on our upgrade mirror path for exciting higher end primary mirrors for those who want to go for those. And so this process over the next couple of months is just going to be refining our design before starting to get all this metal cut up. The plastic parts are really easy to revise. The metal parts are a lot more difficult and expensive to revise. So those are the ones that need to be right from the start. And so we'll be doing regular updates. We'll be doing daily or semi-daily updates for our early access customers. And then for those who haven't joined us on the early access campaign, we'll at least have weekly updates for everyone who signs up for Bloom. So that will keep you apprised of what's going on with the prototyping. We have a big Trello board with all of the different kind of action items that are prioritized by how important they are. We have a new Pi Finder that is going to be bigger and even better. It's going to be awesome. So working together with Richard on that is super exciting. I can't wait to get my first prototype Pi Finder board. So we have just a ton of super exciting development process coming up here to share with all of you. I don't know. I think it's I think it's a lot more exciting to actually see all of this stuff come together than just to see sort of marketing gloss from a company that's kind of just keeping all that under wraps, and you don't ever have any sort of interaction with the people who are designing the stuff. You just sort of have interaction with customer service and maybe with salespeople. So this is a real different way to get your astronomy gear. So thank you to everyone who is joining us on this journey of doing things a little bit different. So all right, well, I'm going to sign off for now, and all of you have some very clear skies. It's a little bit sunny here in Oregon. I doubt that's going to hold, but I don't know. We'll see if let's see. Is there anyone going out in the group chat? I am not seeing the group chat, so I'm guessing there must be some clouds moving in tonight. So it looks like I will probably not be going out with any binoculars tonight to celebrate the closing of the pre-order campaign, but maybe later this week. But I hope all of you get to do that. Clear skies wherever you're at, and swing on by to members.analogsky.co, sign up for free, join our community, and I don't know, just tell us what it was like looking at the sky. That's what we love to talk about. So, all right, we'll take it easy, everybody, and we will keep you posted on how this number is moving. Up, up, up.